Alright, so here's the different types of experimental designs. An experimental design example. Consider the following hypothetical experiment. Acme Medicine is conducting an experiment to test a new vaccine developed to immunize people against the common cold. To test the vaccine, Acme has 1,000 volunteers, 500 men, 500 women. Okay, the participants range in age from 21 to 70. Okay, now we're going to look at the first one, which is the completely randomized design. The completely randomized design is probably the simplest experiment design in terms of data analysis and convenience. With this design, participants are randomly assigned to treatments. Okay. Now you could split up each 500 to placebo and 500 to the actual treatment and measure it that way, but you don't need to actually do that type of thing. You need to be able to randomize the numbers of which persons go where and just have it be that way. Okay, so the completely randomized design is probably the simplest and easiest, but it does have some issues with Simpson's paradox and lurking variables. So you do have to be very careful with this one, okay? Okay. Now placebo is just basically, it's the control. Well, it's in an experiment, subjects respond to differently after they received a treatment, even if the treatment is neutral. A neutral treatment that has no real effect on the dependent variable is called a placebo, and the subject's positive response to a placebo is called the placebo effect. To control for the placebo effect, researchers often administer a neutral treatment, i.e. a placebo, to a control group. The classic example is using a sugar pill in drug research. The drug is effective only if the subjects who receive the drug have better outcomes than the subjects who receive the sugar pill. So in other words, placebo is when someone believes that they're actually getting some type of drug and then psychologically they affect the outcome of it. It's very easy to account for with a control group and the actual placebo effect, or the placebo drug. Okay, now randomized block design. The completely randomized design is possibly the simplest experiment, the experimenter divides participants into subgroups called blocks, such as the variability within the blocks is less than the variability between the blocks. Then the participants within each block are randomly assigned to treatment conditions. Because this design reduces variability and potential confounding, it produces a better estimate of the treatment effects. Okay. Alright, so in other words, if I were to take those 1,000 people right here and I would break them up into 250 men getting the placebo and 250 getting the actual treatment, and out of the 500 women, 250 getting the placebo and 250 getting the actual treatment. Okay, so it works that way. This actually, randomized block design, helps deal with the fact of working with the confounding variable, or sorry, the Simpson's paradox, where you're grouping everyone together, but then when you look at the subgroups, you get a completely different picture. So randomized block design is a little bit better than the completely randomized design. Okay. Just for note, some blocking designs, individual participants may receive multiple treatments. This is called using the participant as his own control. Using the participant as his own control is desirable in some experiments researching on learning or fatigue, but it also can be a problem. Medical studies where the medicine used in one treatment might interact with the medicine used in another treatment. So you have to be careful when using this one. Okay. And blocks perform similar function in experimental designs as strata perform in sampling. Both divide observations into subgroups, however they are not the same. Blocking is associated with experimental design, and stratification is associated with sample surveys. Alright, now matched pair design. A matched pair design is a special case of the randomized block design. So in other words, it's a subset of the randomized block design. It is used when the experiment has only 2 treatment conditions and the participants can be grouped into pairs based on some blocking variable. Then within each pairs participants are randomly assigned to different treatments. So sometimes they might, sometimes the first person might be doing the placebo, sometimes they might be doing the treatment. It randomly assigns it and everything. Okay. Now this one explicitly controls for 2 potential lurking variables, age and gender. So in other words, you could pair up 2 women, both age 21, and have one have the placebo and one have the treatment, or you could have 2 women age 50, one have the placebo and the other one have the actual treatment. So you could actually switch it up and just work with it that way, and you could actually have the 2 women be there. It just helps out when working with those lurking variables. So match pair design, it does take a little bit more time, but it's a really good one for you guys to use when you're trying to use a different experimental design. Okay? Alright, and that's it for experimental designs. I will talk to you guys later. Have a great day. Bye.